Hello everyone. Today is the 51st day of Leetcode Solution challenge. Let's begin with the 51st question. Question 2542, maximum subsequence score. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given two zero indexed integer arrays which are called nums1 and nums2, both of length n and a positive integer k. Okay, so we are given two list, we could say, or array of length n, and a variable k is also given. So our task is to select exactly k indices from these arrays to form a subsequence. Okay, so basically k helps us to take a subsequence from the given array. And okay, the score of the chosen subsequence is calculated using the formula given below. It is basically sum of the selected elements from the nums1. Suppose if there are n elements in nums1, so we selected 0, 1, and 2, which is equals to the k. If k is given as 3, the minimum of selected elements from nums2. So with this same indices in the nums2, suppose let me write it in more clear way. So basically, if you take a 0, 1, and 2 indices from nums1, suppose n1 is nums1, and similar indices or the same indices you have to take from nums2 also. Okay. Now, sum of the selected nums from nums1. So you will take the sum of the values from of these indices from nums1 and minimum of the selected elements from nums2. Now from the same indices, there would be some values to 0, 1, and 2, right? And from among those values, you will take the minimum one. Okay. For example, the sum for this comes out to be 8, and the minimum from this comes out to be 3. So it will be 8 3 24, right? So this will be our output. That is basically if you pick indices 0, 1, and k minus 1, the score becomes this, which I basically showed to you. Okay, this is what our question is asking. So you need to find and return maximum possible score that can be achieved by choosing exactly k indices in this manner. So basically, we have to return the maximum uh, possible score. Find using this particular formula. We have to design an efficient algorithm to compute this result within the constraints. Now, if you focus on the constraints, the length of nums1 and nums2 will always be equal. Okay, and the n value will be from 1 to 10 to the power 5. And thirdly, nums1 and nums2 value could be from 0 to 10 to the power 5. The values of nums1 and nums2, okay? And k could be from 1 to n. Basically, k could be equals to n, or basically you could say the length of the nums. Fine. So basically, they are asking us to take out indices, which will be equals to k indices, if it is 3 or 4, whatever. And similar indices will be taken from nums1 and nums2. And here you will take the sum, and in nums2 you will take the minimum, and you will just multiply them. Okay. I hope you understood the problem explanation. Now let's move to the next slide. Now let's understand the input output explanation. Suppose if you see here in nums1 we have 1, 3, 3, and 2, right? And let these be the indexes for nums1, and for nums2 you're having basically 2, 1, 3, and 4, right? And the indices are 0, 1, and 2, and 3. Okay, and k equals to 3. So basically I can choose three indices from this particular nums, and similarly from this. Okay, and output is 12 here. Okay, now if I choose to take indices from here 0, 1, and 2. Okay, so what is our sum? What are the values basically? It's 1 plus 3 plus 3, right? So it comes out to be 7. Great. Now if from here, from 0, 1, 2, if you see here, the minimum is 1, right? So 7 into 1 gives me 7. So okay, so we have 7 for this particular case. Now I will store it somewhere. Let it be answer here. Okay, it has the 7 now. Now let's try some other indexes. Now let's take indices 0, 2, and 3. Fine. So the values for those indices are 1, then 3, then 2. So there's some so 2, 6 basically, I guess. Yeah, 3 plus 2, 5, 1 plus, okay, 6. And for this, if I take, we have to take the same indices, right? For this same 0, 2, and 3, right? So it is 2, 3, and 4. And the minimum out of this is 2, right? So what we will do, we'll multiply this and we will get 12. So we'll replace this with 12. Okay, because this is the next maximum, right? So similarly, if you try more combinations, This is the one you will get the maximum as the 12 as the output. So this is what is given to us, and yeah, this is the input output explanation. I hope you understood what we are trying to do here basically. So let's move to the next slide. Before going to the further slide, let's understand what is min max heap or min heap or max heap concept. Fine. So what is a heap? It is a spatial binary tree or a complete tree where the value of each node is either, in min heap case, smaller than or equal to its children, max heap greater than or equal to its children. So basically, it stands like this. This is a tree, and if you're looking for min heap, how it works? Okay, let's see here. Every parent node is less than or equal to its children. Suppose if this is -1, it will be 2, and this will be 3. It will be 5, it will be 6. Okay, it will be 10, it will be 20. So if you could see, so this is a parent node, and this is smaller than any other node present here for in the children. Okay, 2 is the parent node, and 5 and 6 are its children, and these children are greater than the parent, which is 2 here. That is what it's written here. Every parent node is less than or equal to its children. Okay, the root contains the minimum element used when you use to fast access the smallest element. So basically, every parent element will be smaller than the children element, and for the max heap, it will be opposite. Every parent element will be greater than its children element. So here you could see this is the parent element, right? For this, all the children is below it, and it is greater than the all the children present under it, right? If we take 10 as the parent element, 6 and 5 and 8 are smaller than 10, 10, right? Because 5 and 8 are smaller than 10. Similarly, if we take 11 as the parent node, 2 and 3 are smaller than it. So what is written here? Every parent in a max heap case node is greater than or equal to its children. So basically, if this is the maximum element, okay, all its children will be minimum to it. This is the maximum element. All the children below it will be minimum to this, fine. And this will be minimum to this particular node, but this will be maximum to the below children's, fine. This is how it goes. Now, why it's efficient, right? According to the time complexity, if you could see, insertion takes log n time, deletion of minimum maximum takes log n time, and picking of the element take O(1) time. Now, here I've done reheapify. Reheapify is the concept of how the heapify thing works in a tree, right? How heapify works. So basically, it means that whenever you delete a node, we have to reorganize the complete tree, right? Or how to delete a node in the middle, or how to delete a node at the end, right? This is what a heapify does. So this is a different concept or different thing to learn about. I will create a different video for it. Fine. A space complexity comes out to be O of n if we store the elements. Otherwise, 0. Okay, or O of 1. Now this is mostly efficient for solving the kth largest smallest element problems, priority queues problems, median finding problems, and heap sort kind of problems. Fine. Where mean max heap is used. Okay. I've written some kind of questions here, or you could say examples of things where you could use this particular topic. Okay, in priority queues, it is mostly used in C++. You could use this concept. Okay, like elements with high priority are served before the lower priority. Priority queue is basically mean heap only. Okay, and max heap. But in uh, Python, if we focus on Python, there is nothing such as a priority queue directly. Okay, so what we do, we use Heapq to solve our min max heap concept problems. Fine, which is the concept of Heapify also here. Okay, we'll learn about this. Now, Dijkstra algorithm uses this min heap concept. Top K problems uses this min heap concepts when we have to find the largest or the smallest element efficiently. Heap sort uses the min max concept, and it takes n log n time complexity. Okay. A median of a string use mean heap and max heap together to maintain the lower and upper halves of the data. So these are the questions, examples, or topics where you could use the mean max heap concept. Okay. So I hope you understood the concept of min max heap. Now let's move to the next slide. To understand what problem is asking, let's build up an intuition to the problem. And let's start by understanding the goal first. Okay. So we are given two arrays and nums1 and nums2, both of the length n. Okay, we are clear with this thing. And we need to choose a subsequence of exactly key elements, selecting the same indices from both the arrays. Please keep this in mind. Uh, Let me write some indices here. Okay. So these are the indices of an array. Okay. I hope you understood this. Now, suppose this is nums1, we understood that, and this is nums2, and this is 0, 1, 2. and 3. So if I choose 0, 2, and 3, here also I have to choose 0, 2, and 3. Okay, please keep that in mind. And for this, we have to find the sum. And from there, we have to find the minimum value. Okay. Now we understood the formula that the score of the chosen subsequence would be sum of nums1 multiplied by the minimum value from the nums2. Okay. Now our goal is to maximize the score. So it is not necessary that whatever value which we got in the first chance of doing the particular thing will be our answer. So we have to basically try multiple combinations, okay, to basically find our answers. Okay. So I hope you understood this thing, the goal, what we have to basically do. Okay. Now let's try to visualize the process. Okay. Let me take an example here. So I have taken this example. The indices are 0, 1, 2, and 3. Similarly, here also 0, 1, 2, and 3. Okay. Now, to get the maximum output in general case, get the maximum output, what we can do? The first thing which can come to our mind is we have to multiply the sum with basically the greatest number so that output comes out to be a greater one or the maximized one. Yeah, we have to choose the minimum element from here, but that minimum element has to be the maximum one so that our sum, which we get after doing the multiplication, is greater. So what we can do? What I'm trying to say here is that we try to take the maximum element from the nums2. But it has to be the minimum if it but it has to be the minimum, but it has to be the maximum. What I'm trying to say here basically is that if we sort this particular thing, what we get? Uh, 4, 3, 2, 1, right? We get this. Now, the indices or the index for the 4 was, let me write the index here. It's 3. Okay. For the 3, it was 2. For 2, it was 0. And for 1, it was 1. Now, suppose whatever sum you took, okay, whatever indices you took from here, whatever, and it turns out to be 6. So your main goal is to be or should be to get the maximum values of k's, basically how many k's, what is the k value given to us? Suppose it is 3. So you try to take the maximum 3 values, and from that you will take the minimum one, right? And if you take that minimum one, it will be kind of a greater element, which would give us a output, possible output, not the actual output. Let me give an example to you. And how we can do that thing is by, let me write it again. Okay, so I have done some changes here. If you could see what I tried writing here, point 2.1. Let's try pairing each element as nums1, nums2 to work with both arrays together. Okay, and if you could see, I have sorted this array or the nums2 in the descending order. Like we tried sorting the element in the descending order. Then we can try the largest minimum first. Maybe they give the better score. Yes, this is what I was trying to explain earlier, that if you take the k values, which are basically from maximum to the most maximum, could be our chance to get a value. To be in a precise, easier manner, what I'm trying to say here, if suppose let k be 3, okay, and if I take this, okay, and we have to take the same indices. If I am not wrong, okay, we have to take the same indices. Okay, I have marked the indices wrong here. Let me recorrect it. So I have now written the basically the indices here. Now let's go. So first thing what I tried doing here is that I have sort the num2, and since we have to take the same indices, I have also taken or basically written the parallel values for those particular nums2 values. For example, if we have taken 4 here or the index 3, we should have taken or we have to take the index 3, which is value 2, right? Same here, but I have after sorting in index 3, if you take index 3 here or the first value from the descending array, the corresponding will be 2, right? Similar thing, that is the thing which we have to do here, okay? This is what after sorting we got. Now, suppose I am saying that I have the value k, okay? I'm saying that 4 is my minimum value, okay? Now, if I take this, I have to take this corresponding value, right? If I take this corresponding value, it's 2. But since I have said that 4 is my minimum value, I'm not going to explore more values, right? If I go to the left, hypothetically, if I go to the left, there are no more values, right? And since I have taken only one values, I have to take two more values, correct? So what I will do, I will move ahead. I'm saying now that 3 is my minimum value. Okay, 3 is my minimum value. So till 3, how many values did we got? We got 2 plus 3, correct? But still, it does not fulfill our condition because we required 3 values, right? I said, okay, no issue. I will try to take this value, 2. I'm saying now that 2 is my, you could say, the minimum value which I will take to multiply the sum. The value corresponding to 2 or the index 0, which is 0, right? And it's 1, right? So I will write 1 here. Now I can see that I have all the 3 values with me, correct? Now this is the sum. Now sum comes out to be 6 if you get the value, and if you multiply this, we get 12. And if you remember this example I have taken from one of our input-output explanation, right? And for that, if you can recall, we had the output as 12, right? And for that, we similarly took 0, 2, 3 indices, or basically 1, 3, 2 values, okay? And 2 was the minimum. And here also the same case which we have taken here, which is it is 0, 2, 3, or it's same because it's 3 and it's also 3, right? Or you could say 0, 2, 3, right? So we got the same thing. Now, we got this as the output. Now, you don't know whether this is the maximum output or there are multiple cases to it, right? There could be 13, 14. You don't know that, right? Now what you will do in that case? Now, there could be a case that the sum which we took, which is basically 2, 3, 1, resulted in the output of 12, right? When we multiplied it with 2. Now, there could be a case that if we have taken there might be some other values here. In the case of 3, it might have been like 15, right? So if this 15 was included in the sum, the output might have been greater, right? This is in a hypothetical situation. I'm just assuming here. So in that case, since you had only 2, 3, 1 in your array for the summation, and you're standing at 2, now if you have to take more new 3 pairs, right? Now you have already taken this pair, right? Now if you want to include this 3 to the pair, suppose it's 3, right? Or if it's 15, whatever, right? What you have to do? You have to keep the sum maximized from your end. For that, you will try to remove the minimum value from the sum, so that when you remove this value, the minimum value, which is 1 here, you have the maximum sum as possible after reducing the 1, and then you add this 15. If you take 15 here in case of 3, or if you take 3, right? If you add also 3, you get an output as 3 plus 3, 6, 7, 8, right? That, right? And in that case, you might have to take this as 1, right? And in that case, this becomes 1 as the minimum. And you multiply it into 1, you get 8. Yeah, the output is still smaller than 12, but here what I'm trying to explain you is that since you had 2, 3, 1 with you, and you had the sum, and it was 6, right? Up to this point. Now you thought that I will go ahead and I will take in some more combinations. Okay. In that case, you have to remove some values from the previous combination, right? Or subsequence. So in that case, you will try to remove the minimum value from the subsequence. Reason being, you have to keep your sum as maximum as possible, right? What you do, you try to remove the minimum value, which is 1. I'm trying to explain it to you again, right? Now you have 2, 3. Now you went here, you have 3 in the ahead part, right? So you added 3. So you got the sum as 8. Fine. Now to remove always the minimum sum, you have to or not the sum actually, the minimum value from the particular sum every time. What you could do, because you cannot just rely on one of the combinations and move ahead, right? The combinations might differ. So for that, the most important thing you could use is the mean heap. Here I have written here itself to keep track of the k best nums1 value. This is nums1, right? Maybe using a mean heap will help. Yes, it will help, because that way we can always remove the smallest if a better one comes along, right? After the initial k, we could keep sliding through the remaining pairs. At each step, we try to replace the smallest nums1 in our heap with a new one, right? Because every time we compute a new score with the current nums2 as the potential minimum, because If you take 4 as first, this is our potential minimum that, yeah, we are taking 4 as a potential minimum. But the minimum capacity, or the required capacity for K is 3, right? So you cannot just take 4. Then you try to take 3 and you say that we are taking 3 as the potential minimum for our multiplication. Then you come and you take 2 as your potential minimum, right? You take this as a potential minimum. Now you have seen that you have completed all the 3 values required for the sum and you did the calculation. After that, you went and you came here at 1. Fine. Now this is a potential minimum, but since you came here and you have already these 3 values with you, it's fine. But you have to remove the minimum value from that subsequence so that you can take the next maximum or the next value, so that you can form a new combination and you can check out the sum or the maximized value. So this way, here to remove all the minimum values from the subsequence, we will be using main heap, right? And in here we will be just sorting it in a descending manner. This way, we always get the minimum value as the potential minimum value in each iteration. Okay, and you remove always the minimum value from the subsequence so that you get the maximum sum. And when you multiply both of this combination, you get a maximum output. So this is what the visualization process could be or will be of this particular problem. Okay. So this way we have built up our intuition, right? Let me clear this part. So in short, what I tried doing is that I sorted in descending order. Okay. And after that, in nums2, I used min heap. Okay. To get the minimum value and to get the potential minimum. Okay. I hope you understood this visualization process. Now, how we can simulate this, right? What we can do in Python, we can try pairing the elements from nums1 and nums2 using zip. Okay. This is the method used in Python to get a list of nums1, nums2. So how this will happen is that we will create a pair of nums1 with nums2. Okay. This will create a pair. Okay. So basically zero index with zero index, basically this way. You would say this way. And after that, we sort this paired list in descending order based on the nums2 to prioritize higher potential minimums. So after that, when you make the pair using the zip, we try to sort it using the descending. Basically, we are sorting in the descending order based on the nums2. So what happens? This zip, which is created, basically, if it is 1, 2, 3, 4, right, and this is let it be num1. Suppose this is 1 comma 1, and then it's like 1 comma 3. Suppose 1 comma 5, not 1. Let it be 2. Let it be 3. Okay. So when this is nums1 and this is nums2, right? So when I sort this in a descending manner based on nums2, prioritize the higher potential minimums. So this basically becomes 2 comma 5, then 3 comma 3, then 1 comma 1. It's in descending order based on the nums2 value. Got it? So this makes us easier to get its adjacent value so that we could get its sum and multiply it. Then we use a min heap to track the best k values from the nums1 for score calculation. Pretty easy. First k values are kept in in min heap. So whenever the another value is considered, the minimum value gets popped and the new value gets entered. Okay. So we maintain a variable current sum. We will do that, and to store the sum of the values inside the heap, which is necessary because in each iteration we have to know the sum so that we could calculate its product with the minimum value. So we add the first k nums value to the heap and update the current sum. Since we know that we need k values, right? K could be anything from 0 to n or 1 to n, whatever the constraint was. So to make our life easy, what we'll do, we will already put the k elements in our min heap. Okay, and we will take its sum so that when the k plus 1 element comes, we could remove the minimum element from the heap. So it makes our work easier. We calculate the initial score at current sum multiplied by the nums to k minus 1. This is basically if k is 3, in index wise values, it will be 0, 1, comma 2, comma 3, comma 4. So if it's k is 3, then it will be 2, right? So if we do k minus 1, we get 2. So in nums2, since it is sorted in descending order, we will directly get the value of the second index. Fine. For each remaining element, we remove the smallest from the heap and add the new nums1 to the value. This is the common practice, and update the current sum and compute new score using the current sum of nums2. We update the max score if the new score is greater than the previous best. So this is basically after calculating the first iteration of the k values and the product of it, we keep on going ahead and keep on popping from the min heap and enter the new value, so that when we get a new, much more better combination to the previous one, we update it. So that's what it's written here. We will understand it is much easier way when we look at the approach. Now what we figured out? We figured out that sorting by nums2 in descending order, let's start try larger minimum first, which can lead to a higher score. Common practice, because if we have the larger value, which is and also that is our potential minimum, we will get a maximum value. We have the chances of getting the maximum value, right? Using a heap helps us to always track the best k values from the nums1 as we go. In min heap, we'll always store the values in the ascending order and we pop the zeroth element from it. Take it in that way. So every time we pop the minimum element and we put a new one. So because of that, we get a better combination each time. The heap allows efficient update of log k time. Since we are using main heap, and if we understand the concept of main heap, it takes usually log a time to do the operations of it. Okay. And at each step, we calculate the score using the current sum nums2 as the minimum and the heap sum as the multiplier. So what we're trying to do, whatever the values are there in the min heap, we make the sum of it. And in the array, after the no, first we consider suppose k values initially, and after that we go ahead, right? So whenever we get a new value, we have the value with us in the min heap, we multiply it with this particular new values each time. So this is what it's written here. And this balance between choosing a large minimum nums2 and maximizing the sum from nums1 is the core idea. So this is what we figured out after solving the problem, that we have to use min heap and we have to sort the nums2 in the descending order so that we could get the value. So I hope you understood the intuition. It was pretty straightforward and simple, and I tried to break it down in the easier way as much as possible. So let's go to the next slide. Now, since you got the intuition of the problem, let's look into the approach, how we're going to solve it. The step one, we pair and sort the elements. Okay, we pair each element as nums1 and nums2 using the zip nums1 nums2. This basically makes pair of 0, 0 index, then 1, 1 index. This is what we are doing here. After that, we sort the pairs on the descending order of nums2. Now this is nums2, right? And if we sort it in the descending manner, the greatest value from this particular index will come ahead and it will follow the particular thing. That's the thing. It's simple to understand, right? Nothing much complex. Because nums2 is the minimum value in the final score, right? And starting from the largest possible values help us to test better multipliers early on. So this is the greedy way which we are trying to approach here, right? That's the thing. Now in step 2, we initialize the data structure. We create a min heap to store the top k values from nums1 this way. And initialize a variable to keep the sum of elements in the heap. So basically this is the min heap and this is the sum of the min heap. And also track the maximum score encountered so far. So we have the max score equals to 0, which will basically have the current sum multiplied by the uh, nums1 of I, whatever the value which we have right now. That's the thing. We want to maintain the highest possible nums1, right? Sum efficient while only keeping k values at a time and calculate score as we go. Now at step 3, we process the first k elements initially, as I explained earlier. We loop over the first k elements from the sorted pair of list. And for each, we add nums1 into current sum and push it into the main heap. Simple as that. So we consider first k elements and we do operations on that first, okay? And in that, we keep on adding the sum. Basically, in the current sum, we keep on adding the values, create a sum of k values, and we put that value back into the main heap. But that is what we are doing here. And after the loop, we compute the initial score by taking the, since we have taken the k elements and the nums2 is already sorted, so we take the kth value and we multiply it with the current sum. So we to get the definite max score for that particular range. Okay. Why we are doing this? Because we start by picking the top k candidates from the largest nums2 values and form our first possible subsequence. Now at step 4, we slide through the remaining pairs. Basically, after doing the first k elements, we have to look for the other pairs, right, in nums2 and nums1 both. So for that, what we have to do? For each element from index k to n minus 1, since this is the array and till here you have already done, Now we are left with this part, right? So this is basically this is k minus 1. So we have to start with k to n minus 1. Makes sense? So we pop the smallest value from the heap to maintain exactly k elements. Now in n1 we have taken the value still k minus 1, right? And we have those value in our min heap. Now since from here we came to this part, the values has been increased to k or k plus 1 you could say. Okay. Now since it has been increased, we have to remove one of the values from the min heap, and it makes sense to remove the smallest value. So we pop the value from it, or we can do min heap 0 or whatever, and we add this value into the min heap. And the value which is removed from the min heap, we also subtract it from the sum, and then we add the new value into the sum from the kth index. Make sense? It is what written here. Then we compute the new score with the current sum and nums2 of I. Fine. We update the max score if the new score is higher. Otherwise, we move ahead. Why we are doing this? We are trying every possible nums2 as the minimum while adjusting the nums1 values to keep the sum as large as possible. Because you cannot just stop at first k values of the nums2, which we sorted in descending order, and claim it as the output. Because there could be a chance that if you have taken the next value or the further values, and the combination because of that which you are getting, the sum is such a high value that it might result into a greater value compared to the previous one. This might happen, right? So that is why we have to look for every values. Now at this step 5, we return the result. That's all. After going through all the options and we return the max score. This is the highest score possible using the rule sum of the chosen nums1 into the minimum chosen of nums2. So I hope you understood the approach explanation. I know it was much more in theoretical manner than drawing the diagrams, but it is a thing to be explained in that manner only. So let's move to the next slide. Now the code is the exact copy of the approach discussed. Let's understand it line by line. So this is the code, as you can see. Yeah. So we have taken the length of length of nums1 because both nums1 and nums2 have the same length. Now this is the paired values, and this is the sorted values in the descending order. Basically, this variable contains the combination of nums1 and nums2 in pair manner, like 0, 1, whatever. And after that, it is sorted on the basis of the nums2 values. Okay, this is I guess you understand this thing, right? After that, we have declared min heap list and a current sum variable. Yeah. Now for the k 0 to k, right? For the first k elements, we take out its complete sum or the product of whatever the max score was. Okay, we do that by adding the sum. If you do I of 0, we get the value of nums of 1, which is basically this side, right? Then we put that value into our min heap. Make sense? This is what we do. And after doing for this complete range, what we do, we have the current sum. Then from the paired values k minus 1 of 1, it basically says that go to the k minus 1 index in the paired values, which is, let me draw it, okay? It will make more sense then. Yeah, so this is suppose the paired values array combination of nums1 and nums2. These are the pairs, right? Suppose this has some random values to it. I just written the random values, please don't go into it. Okay. So this basically says that go to the k minus 1 index. If k is 3, you will go up to k minus 1, which is this part, right? Because it is zero based indexing. And 1 means take the value from the nums of 2. So nums of 2 is this, right? So when I write paired values of k minus 1, this goes to the index of this particular list, which is basically 2. And if I write 0 here, it will give the nums1 value, which is the left hand side value. If I write 1, it will give me the nums2 value, which is the right hand side value. Make sense? So after doing that, we get the value in the max score for the first k values. Then we iterate the leftover ones from k to n, and we take out the smallest from the heap. Okay, it does it automatically. We add it to our current sum, and we subtract it from our current sum. The value which we basically pop from the main heap, which is smallest in heap, we subtract it. Makes sense? And we add the new value to our main heap. Makes sense? Now current sum is done. Now we have to push these paired values or the value which we have added into our current sum into our main heap also. So that is done here. And we calculate the current sum, which is we calculated here, and the paired values of that particular index, right? And at the end, we check whether the max score, which current score which you got, is it greater than the max score or not. If it is, we update the max score. Otherwise, we don't. And after that, we are returning the max score. So here, when I do this, In the nums2, basically, take this way. You did it from 0 to k, right? Or k minus 1. Now you started from k. Okay. So you have to look for every values, right? Every potential values in the descending order. Therefore, suppose you did it till here, right? Now you started from this particular part. You added this value, you subtracted the minimum value from this range. Understood? Secondly, since this was the last value you took to multiply, now you came here. Now you're taking or you're considering this as the potential minimum. Fine. That's why I'm multiplying this in here. And each time you go ahead, you do the same thing. So I hope you understood the code explanation. Now let's look at the time complexity. So the time complexity, if you can see, is n log n. Reason being, the zipping part or the making the pair takes n log n time complex. Oh, sorry, O of n time complexity. Fine. After that, we sort the values right here, and sorting usually takes in if you use the sort algorithm directly, it uses a merge sort in most of the cases, which takes n log n time complexity. Fine. And after that, we do the heap operations here, and which take log of k. This is the time complexity for doing any operations in the heap. Fine. Therefore, when you do it here k times and here n minus k times. Fine. So what happens in overall n minus k multiplied by log of k, because here you're doing the operations or you're going for k, which is constant, right? And you're taking log k time complexity for doing this. Fine. But here you're doing n minus k times, and you are doing the operations which takes log of k times because the size of the heap is k. Fine. Which boil down to n log k in the worst case scenario, right? However, since k could be less than or equals to n, fine. Therefore, we could say n log n. Therefore, the output for our or the time complexity for this particular code comes out to be n log n. Fine. And space complexity is O of n because since heap is storing the values which is equals to k, right? And k value is less than equals to n again. So if the k value is equals to n in the worst case scenario, therefore the space complexity becomes O of n of this particular min heap, right? So I hope you understood the code explanation. Now let's move to the next slide. Now since we have the understanding of the code, let's look at the dry run of the example. So I have brought down the code here for a better understanding. So let's start with the dry run. So this is what nums1 is given to us, and this is nums2. Fine. So according to our problem or the code, if you could see, ignore this part. Okay, paired values, right? Now we will zip the values and we will put the lambda to it, or we could sort the values on depending upon the nums2. So I will create that pair directly here. Fine. Okay. So I have created the array, or basically you could say the paired list of array. Nums1 is nums1 comma nums2 zipped and then sorted on the basis of the nums2 in descending order, which I have already done. If you could see, nums2 is this, right? And it starts 10, 9, 7, 6, and 5, right? Now, let me create a min heap here. Let this be the min heap. Fine. And I will update the current sum here itself. Let's go for the k. Okay. First k range. Now, for the first k range, if you go, what is the current sum paired? If I take pair of I of 0, right? It's 3. Then we push it back here. Then it's go ahead, it's come here, it's 1, right? And push back in the main heap. This is the main heap. Then next, what is the k value? Oh, so my bad, k is 1. So okay, k was 1 here. So this is done, right? Since k is 1, we will be having only one value in the main heap, and the current sum becomes 3. So we come out from here. And what is the current sum right now? It's 3, right? Multiplied by the k minus 1. Since k is 1, 1 minus 1 is 0. So we have 10 here. So we'll multiply it by 10. And what we get? We get 30 as our max score up till this index. Okay. So I will write it here itself. It's 30. Great. So we'll move ahead. Now we will start from k to n minus 1 in this particular range. Now the smallest in the heap. What is the smallest in the heap? It's 3 because the k is 1, right? So what we did, we popped it and we stored it here, which is 3. Then current sum. Now the current sum was 3, right? Then we added what? We added 1 and we subtracted 3, which is the mini heap. So this got cancelled and we remained with 1. So our current sum is 1 right now. And we push this particular 1 into our main heap. Make sense? What is the current score? Its current sum is 1 and paired I of 1 is 9. We multiply this and we will get 9, right? And since we already had max score as 30 and the current score is 9, 30 is greater than 9, so it remains as it is. And we move ahead. Right? Now, since we moved ahead and came here, we pop this one, and instead of 3, now it's 1 in the smallest in the heap. Now the current sum was 1, right? We added, what is the value here? 4, right? We added 4 here and subtracted the 1 which is smallest in the heap. These two get cancelled and we have 4. Right? Nice. And we add this 4 into our main heap. Great. Now we can calculate the current sum again. Since the current sum now is 4 and the adjacent value for this is 7, it gives us 28, right? Now, since 28 is the current score, and if we compare it, 30 is still greater than 28, so it cannot be replaced. So our max score remains same as it is. Again, we came to the third index. Now it's 1,6. The smallest in the heap is 4 right now, fine. So let it be 4 here now. And current sum is 4. We add its value, which is 1, and we subtract the smallest in the heap, which is 4. So this gets cancelled. So we basically remained with 1, right? And we push it back into the main heap. Okay, done. Now, what is the current sum? It's 1, right? And the paired value with it is 6. So you get as the 6 output, and still current sum is smaller than the max score, right? So we move ahead. Now we are standing at the last index. Now the smallest in the heap is 1, right? So we pop that value, keep it here. Because the current sum is 1, and the new sum here, value here is 2. We put 2 here from here basically. I'm sure you're getting that part. We subtract the smallest in the heap, which is 1. So this get cancelled, and we are remained with 2. Fine. And we push this basically 2 into our main heap. Okay. Now we have 2 in our main heap. Now we calculate the current sum. Since the current sum is 2 here, it is multiplied with the paired values 1, which is 5 here, and it gives me 10, right? And if you can see, 10 is still smaller than 30, right? After that, when we go ahead, the iteration is completely done. Now the max score which is left with us is 30, right, at the end. So therefore the output is 30 for this particular problem. So I hope you understood this dry run. If you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach and the code, and also if you don't know the concept of mean heap and max heap. After that, do a dry run by yourself in 2-3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. So let's move to the next slide. Now, since we have familiar with the problem and the solution, let's move to the lead code and code the solution. First, we will start by taking the length of the nums1 or nums2, whatever. After that, paired values. This will be the list on, we zip it, basis of nums1 and nums2, and paired values will be equals to um, sort, and this is a lambda function which we'll be creating here, lambda pair and pair of 1 comma reverse to true. So basically this means that pair of 1 basically says is that we have the value this way, right? So this is 0 index, this is first index, this is 0 index, this is first index, right? And when we write pair of 1, this basically says that from this pair which you have created, take this value, one index value, and reverse it. Okay, reversing means reversing in the descending order. Fine. After that, we create a min heap list and current sum equals to 0. After that, for I in range of k, current sum paired values, it's I of 0, right? And then heap q dot heap push into the min heap, and it will be paired values I of 1. This is the nums2 values from the pair. Oh, sorry. This is the same thing, right? After doing this for the k values, we have the max. We check for the max score and we calculate the max score. Max score is basically current sum into a paired values of k minus 1 of 1, right? This makes sense? After doing this, we go for the leftover values for I in range, and it goes from k to n. We take the smallest in heap value, right? Heap q dot heap pop from main heap, and now since we have let me write it again. Since we have current sum, right? Now we will add the new indexed value basically, right, to our current sum or the subsequence. And since we have popped the value from the min heap, we have to remove it from our subsequence, right? So this is done. And after that, since we have taken or considered a new value, we have to push it back into our min heap, right? Yeah. And after that, we check for the current sum or current score. We go for that. We check we have the current sum multiplied by the paired values. This makes sense. Now max score equals to basically max of the current score and the max score, right? And we return the max score. Now let's try submitting base test cases first. Okay, now finally let's finally submit a solution. So we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find a link in the description. Thank you everyone.